Hey folks, Mr. Dell here. We are looking at a problem where I've got to identify the growth in the type of growth in just given a table, and then really kind of determine if it's linear or nonlinear, if it's constant or not. So this is coming from CPM Course 3, and this is section 9.2.5. So let's start with one table at a time. So actually, first of all, let's talk through this growth, right? I want to know what is the change. Excuse me. What's the change in the y and from each x, right? So what's that change? What is that growth? And then is it linear? If it's linear, it's a constant growth. Okay, linear has constant growth. Non-linear is obviously not constant, right? So if I look going from -1 to 1 to 0 to 1 to 2 to 3. So I'm growing my x each time. My x is growing by 1 each time, right? My x value is growing by 1 in my table. So therefore, I could check the y values and we'll see where its growth is. So if I think about this growth here, that to there, it grows by 7, and then that grows by 1, and then grows by 1 again, and then by 7, and then by 19. So that's not constant. So right away, I know it's non-linear. Okay. Now, if we want to figure out kind of what type of growth it is, I may look to see what operation is occurring to go from the x to the y. Like if I wanted to write the formula, the rule, what do you do to the x to make it the y? So if I was going to write the rule, I'd say what just x, what is x, what's going on to the x to make the y? So if I look at my pattern, I got a 0 stays a 0, a 1 stays a 1. Okay, so that's hard to see what that pattern is here. But then a 2 becomes an 8. A 3 becomes a 27. So if you recognize what I'm seeing here is that it's you've got a cubic situation going here, right? Because what's true? 2 cubed, which means 2 times 2 times 2 is equal to 8. 3 cubed is 3 times 3 times 3, right? Which is equal to 27. So I believe what this is a cubic. It's x cubed. And that would make sense for 0 because 0 cubed, 0 times 0 times 0 is still 0. 1 times 1 times 1 times 1 is still 1. -1 times -1 times -1 is still -1, right? So notice that's how this is growing. So we can say this is nonlinear cubic. That's the growth. Nonlinear cubic. So the growth is cubic. Okay. Um, this one here, let's look at this one. So once again, I'm going to look to see what's my growth on my x's. I'm going by ones each time. So I'm good to go to now just check my growth this way and to see if it's constant. 4 to 6 is growing by 2. 6 to 8 grows by 2. 8 to 10 also by 2. So notice each one of these is growing by 2. So it's a constant growth. So this is linear, okay, because it's a constant growth. Being constant growth, it is linear. And in fact, we can actually go the next step and also write this as a equation. Because if I know my growth is 2, right? Your growth, your slope, if it's linear, it's got a slope. Your slope is your change of y over change of x, right? Your rise over run. And the rise is the change in y, which is 2, over the change of x is 1. So my slope in this case is 2 over 1, or just 2. So when I write my equation, that's y equals mx, so my m is 2, plus b, and b is the y-intercept, and looks like the y-intercept is listed. That's my 0, that's where x is 0, plus 8. So I have a linear, constant growth with that rule. Nonlinear, cubic, so that rule, like I said up here, would be, if I wrote that as a rule, it would be y is equal to x cubed. Okay? All right, there we go.